English, if English is a second language, then, and I go too quickly, then you can whisper to the person next to you, what did he just say? It'll all be fine. I'm going to show this. There's a couple of slides I want to show first. Everybody, can you read the caption here? 2 dinosaurs missing the ark sailing away. Oh crap, was that today? And the reason I say that is because the science around misoprostol has been moving so quickly that if you missed the boat, then you're just that far behind, because whether it's the route of administration or the indication that we're using it for, it really is, it's been moving around very quickly. Even in the time that we've had WHP, we've changed routes of administration for some of our indications, we've changed dosages, so you kind of have to stay current. And usually the bigger the organization, such as WHO, the further behind they are in where things are clinically. Because there's more bureaucracy in getting anything approved for sort of global standard setting. You with me? So that's sort of the first thing. The second thing is that things are again moving so quickly. If you can't read it, it says, in the words of my broker, past performance is no guarantee of future results. Studies sometimes will contradict each other, and so we have to be very cognizant about this, because you could have a study that now the dose or the route contradicts another study, and then we have to sort of put this in mind and say, okay, well, what are the public health implications of that? What does that mean programmatically? Just because study A is in contradistinction from study B, there's probably a little bit of truth in both of them, and programmatically then we have to make decisions about which way we want to go. And that makes it a little more confusing, both for us on the programmatic side and in the field, because they're also reading the literature and they're sort of starting to bounce around like the ball that goes between the bumpers in a pinball machine. So we try and keep the big picture in mind and provide what we think is the most sensible overview with respect to clinical use. So what are my objectives this morning? First, to be able to pronounce pharmacokinetics. Then describe the pharmacokinetics of misoprostol. Pharmacokinetics really just means what happens in the body after it gets introduced to the body by whatever means. How is it absorbed? How does that relate to tissue levels, which is what we're really after. Does this thing have a pointer? No. No. Yes? Yeah, you can move it. I knew that. It's cleverer than I was. So describe the clinical applications of misoprostol. So that's what we're going to spend a little time doing, because there's just a whole stew of things for which we use misoprostol. And then understand the evidence supporting some of these applications, and we'll see how much time we have. So the first one, written in red here, the pharmacokinetics and the routes of administration. Now, misoprostol, and then we're going to talk, we'll also talk about some of these, we'll talk about some of these things here as we go down, like the uses in pregnancy, the uses in I probably won't deal with non-pregnancy too much today, but the uses in pregnancy, and we'll probably get to the uses for postpartum hemorrhage as well. But routes of administration is kind of a big thing, because almost any place where it can be absorbed, misoprostol can be used, and has been used. This is what it looks like. Prostaglandin is actually a natural product. It circulates in our bodies. The ones that we use in medicine are all analogs, so they've been manufactured in the lab to have some quality, whether it's a longer acting quality, or whether it's a more highly absorbable quality. Those are the things that occur in the lab. But prostaglandin is a natural substance. It most especially occurs in the saliva, where it actually helps stimulate the gastrointestinal tract. But misoprostol, the drug that we commonly use in all of our indications in reproductive health, is approved in the U.S. at least for the prevention and treatment. I don't know how to get rid of that thing. Of gastric and duodenal ulcers. And even more specifically than that, it's really approved for the use of gastric and duodenal ulcers that's produced by taking too many steroids. So for example, people who are in chronic doses of steroids for one reason or another, they tend to get these they tend to get these ulcers, and misoprostol treats those ulcers. And that's the only thing for which it's indicated in the United States. Now, due to the work of a variety of NGOs, in some other countries it's actually approved for other uses. But in the US at least, it's just approved for this one thing.
But can you explain that it's commonly used?
Yeah, and so one big difference that is often misunderstood between what we can do with drugs in the US and what can or cannot be done with drugs outside the US is that if a drug is approved by the FDA for something, it doesn't mean we can't use it for something else. The FDA is not the law. The FDA is a regulatory agency, and the FDA largely regulates the distribution of medications. The FDA also doesn't survey the landscape for useful drugs and say, oh, here's a good drug, let's approve this drug for indication X. The FDA only responds to the application of a company to use a drug for a specific purpose. So there could be lots of good drugs out there, but if a company, specifically a company, doesn't come forward and ask the FDA to approve their drug for this specific purpose, it doesn't exist as far as the FDA is concerned.